So before we dive into example 4, I want to make sure that we make the distinguishment between what we just talked about in this last table about arc length versus arc measure. So arc length, we just talked about, it's that part of the rim of the circle, versus arc measure is also part of the rim of the circle. The only difference is whether we're talking about, it's really two different measurements for the same thing. So for example, we're going to be looking for the arc length of LM in this first part of example 4a. So there's two different ways to measure it. One is they tell us in the problem L to the D to the M is 100. L to the D to the M. So we automatically know that the arc measure is 100 degrees. However, this question asks for us to find the length of each arc. So we need this formula in order to find arc length. So arc length is going to be degrees over 360 times 2 pi r. So our degrees is the 100, that's the measure, over 360 times 2 times pi, and I kind of skipped over this part, but the diameter of circle D is 18 units long, so we know our radius would be 9, so times 9, 2 pi, radius 2 pi 9. And then it doesn't specify what kind of answer to leave here, so I'm going to leave mine in simplest, not simplest radical form, in terms of pi is what I was going to say. So I'm going to leave answer in terms of pi, in which case you multiply all the parts of the answer together that are plain old numbers, and you leave the pi out and just stick it behind your answer in the end. So let's look at that in the calculator. So we're going to do 100 over 360 divided by 360 times 2 times, not doing the pi, times our r, which is 9, and that comes out to be 5. So our final answer is going to be 5 pi. So again, don't forget this M means measure. So, okay, so go ahead and pause the video and try part B. Let's make part B a you try, and then we'll come back and see how you did. Okay, you try. Okay, on part B, you said MN is the arc we're looking for the arc length of, and you knew that M to the D to the N is 80, and so then that means the measure of that green arc is 80 degrees. If they were to ask us for the measure, but they didn't, they asked us for the arc length, so we have to go and find a different measure, and the arc length is like, if I were to walk around that part of the rim of the circle, how far would I be walking? That's what you're looking for. So this is degrees over 360 times pi, 2 pi r, just kidding, not pi r squared, times 2 pi r. So that's 80 degrees over 360 times 2 times pi times our radius of 9. So if I leave this in terms of pi, I don't want to put pi button in my calculator. I just multiply everything in yellow together in my calculator. It comes out to 4 pi. Okay, so the last thing I wanted to talk about is what it means to be a congruent circle or a similar circle. So congruent circles are circles with congruent radii. We know that these circles would be the exact same size if they both have a radius of 5, because that means in every direction they would be 5 from the center to the rim. Similar circles, all circles are similar. Because they only have that one measurement, then it doesn't matter how big the circle is. If you have circle and this is a radius of 2 and a radius of 3, then you're just going to have circles at a 2 to 3 ratio. There's no other half to that equation to check to see if it's proportional, because it's always just the one unit of measurement. All circles will be similar. And then lastly, concentric circles. This is just a good word for you to know. Concentric means that they're circles within circles within the circles. They all have the same center, but going out they get bigger. So you can think of it like a target, like a dart throwing target. You can think of it like, the puddle, the ripples in a pond that go out once you drop your rock right here. There's lots of examples of concentric circles, but that's what that means.